A sad day indeed. For the first time in over 3 years, SpaceX missed a booster landing, interrupting its streak as it was on the verge of setting a new record. This unexpected event prompted the FAA to request an investigation, sparking various reactions across the aerospace community. What exactly happened and what's gonna happen next? SpaceX wasn't the only one facing challenges. Another US company also encountered a setback during a rocket test, underscoring the inherent difficulties in developing rockets. Recently, at 3:48 a.m. on August 28th, SpaceX launched a Falcon 9 from SLC-40 in Florida, carrying 21 Starlink satellites into orbit. This mission was poised to set several significant milestones: the 367th launch to date, the 82nd Falcon 9 mission this year, the 342nd landing to date, and notably the 23rd landing of the Falcon 9 booster B1062, a record-breaking reuse that would have further solidified SpaceX's dominance in the field of reusable rockets. However, an unexpected incident occurred that halted these achievements. After stage separation, the booster returned to land on the drone ship a shortfall of gravitas. Everything appeared routine until the booster approached the drone ship. Upon watching the landing video, it was clear that something was amiss. The landing speed seemed unusually fast. As the booster neared the drone ship, its landing legs deployed as expected, but the engines continued to burn, suggesting a potential issue with deceleration. The booster then tilted toward one leg, the flames intensified, and the booster tipped over, likely resulting in its destruction. This marks a significant incident in Falcon 9's landing record, breaking a streak of 267 consecutive successful landings over more than 3.5 years since the last failure in February of 2021. This incident is especially notable because SpaceX has set a high bar for reliability, with each successful landing showcasing the company's engineering prowess. It's worth noting that another Falcon 9 booster, B1058, was lost late last year due to high winds and waves during recovery, a different scenario from this incident, which occurred during the actual landing process. SpaceX has announced that it will investigate the issue to determine the root cause. Based on observations and initial analyses, there are a few possible explanations for what went wrong. Firstly, the engine may not have decelerated the booster sufficiently for a soft landing. The landing speed was noticeably higher than usual, and the engines didn't fully shut down even as the booster was almost in contact with the drone ship, with flames still visible. This suggests a problem in the deceleration phase where the booster's velocity wasn't adequately reduced, leading to a harder than usual touchdown. Secondly, the landing leg may not have locked securely, potentially due to interference from the engine flames. This could have caused the booster to topple over as it tried to land. Additionally, the landing leg might have caught fire, exacerbating the situation and leading to a more significant failure, spreading flames to other parts of the booster and causing everything to spiral out of control. These are just speculations, and I invite you to share your analysis in the comments so we can discuss it further. As expected, the FAA quickly launched an investigation. In their statement, they said, "The FAA is requiring an investigation. An investigation is designed to further enhance public safety, determine the root cause of the event, and identify corrective actions to avoid it from happening again." The FAA will be involved in every step of the investigation process and must approve SpaceX's final report, including any corrective actions. Regarding future flights, the FAA added, "A return to flight of the Falcon 9 booster rocket is based on the FAA determining that any system, process, or procedure related to the anomaly does not affect public safety." In addition, SpaceX may need to request and receive approval from the FAA to modify its license that incorporates any corrective actions and meet all other licensing requirements. While an investigation is necessary, I question why the FAA is scrutinizing a process like landing, which doesn't significantly impact the mission's primary goal of deploying satellites. The primary objective of the mission, deploying Starlink satellites, was achieved successfully, but the focus on reusability is where SpaceX has set itself apart. This investigation could slow SpaceX's progress, especially after the FAA also investigated a recent Falcon 9 second stage anomaly. It could even delay other missions, including the highly anticipated Polaris Dawn. SpaceX's VP of Falcon Launch Vehicles, John Edward, commented, "Losing a booster is always sad. Each one of them has a unique history and character. Thankfully, this doesn't happen often due to the robust design and vigilance of the team. We are working as hard as we can to thoroughly understand the root cause and get corrective actions in place ASAP. One thing we do know, One thing we do know, though, is that this was purely a recovery issue and posed no threat to the primary mission or public safety. Kiko Donchev, SpaceX's VP of Launch, supported this view, emphasizing that the incident was a unique failure in the otherwise reliable recovery process. I hope the FAA concludes its investigation swiftly. Their own statement confirms that no public injuries or public property damage have been reported. SpaceX's strategy of landing on a drone ship in the ocean is a genius solution that minimizes risks to people and infrastructure, further justifying the need for a prompt resolution to avoid unnecessary delays. The incident did not affect the Starlink deployment, which was the mission's primary objective. The impact is on SpaceX's reusability goals, a feat few companies can achieve. The booster's reusability is a cornerstone of SpaceX's cost-saving strategy and its ability to maintain a high launch cadence. Delays in the FAA's investigation could disrupt important missions. Polaris Dawn, for example, might not launch in August as planned. In September, there is Crew 9, and NASA recently selected SpaceX Dragon for the potential rescue of Starliner astronauts. Any delays in the investigation could affect these missions, leading to a ripple effect that could impact SpaceX's schedule and broader objectives. More broadly, SpaceX's focus on landing and reuse distinguishes it from the competition. The FAA's investigations into landing incidents could hinder this trend, making new companies hesitant to develop similar capabilities, thereby impacting the U.S.'s competitive edge in space. The global space industry is closely watching how the FAA handles this, as it could influence the future of reusable rocket technology. We'll have to wait for further updates from the FAA and SpaceX. However, we can be optimistic that the issue will be resolved quickly. In a recent second-stage anomaly, SpaceX and the FAA took just 2 weeks to resume flights, so this landing incident might be resolved even faster. The SpaceX team's diligence in identifying and addressing the issue will be crucial, and their ability to quickly learn from failures has been a hallmark of their success. This incident also serves as a valuable opportunity for SpaceX to review and enhance its systems after a long period of success. Elon Musk commented, "Now we figure out what went wrong to drive the landing failure rate above 1 in 1,000, then 1 in 10,000, 1 in a million, etc." Regarding Polaris Dawn, Musk emphasized safety, saying, "We could have launched and it would have been fine. But safety is paramount, so better to check all systems again." As for the mission hardware, B1062 launched for the 23rd time, marking a significant milestone in SpaceX's reuse strategy and the company's overall excellence. While this might be the final mission for B1062, its contribution to SpaceX's success has been invaluable, and it has paved the way for future boosters to achieve even greater milestones. This may well be the last contribution of B1062 to SpaceX's missions, as it might have reached its operational limit. However, this incident will drive SpaceX to further improve its systems, aiming for even more ambitious milestones, such as 40 flights per booster. Currently, SpaceX has B1061 with 22 launches, B1067 with 21 launches, and many other boosters that have surpassed 10 launches. These will continue to operate, building on the achievements of B1062. During this challenging time, I hope you continue to support the SpaceX team. I believe that after this incident, they'll make a strong comeback, creating new milestones and achieving important goals. Please show your support and gratitude to B1062 by commenting SPX62 below. Then, don't forget to like, share the video, and subscribe to our channel to stay updated on SpaceX's journey. Aside from SpaceX, ABL Space recently faced a significant challenge with their RS-1 rocket during a static fire test. The company ignited the E2 engines, but the test was aborted after just a half a second due to a low pressure reading caused by a faulty sensor. Although the engines shut down as intended, a fire broke out under the rocket fueled by leaks from 2 engines. Efforts to extinguish the fire were hampered by the limited water supply, causing the fire to spread. Eventually, the RS-1 collapsed onto the pad, damaging critical electrical and plumbing connections. The root cause was traced to issues with the propellant injector and liner, likely due to differences in the Block 2 Stage 1 propellant feed system. This incident follows a previous RS-1 launch failure earlier in 2023, underlining the inherent difficulties in rocket development. Alspace, like many other companies in the space industry, must navigate these technical challenges to advance their technology. Despite these setbacks, Alspace remains committed to improving their systems and continuing their pursuit of reliable space launch capabilities. Their experiences reflect the high stakes and the persistent effort required in the aerospace sector, where every failure is a step toward eventual success. Feeling confused? You're not alone. NASA has just released new estimates for the Starship Flight 5 launch date, but there's a lot to break down. On top of that, the eagerly awaited Polaris Dawn mission is facing yet another delay, this time due to weather conditions and new FAA requirements. And in a surprising twist, NASA has awarded a fresh contract for the lunar mission to Intuitive Machines. These developments are shaking up the space industry. We're inching closer to Elon Musk's anticipated launch estimates. But where's the progress? SpaceX seems to be stalled, and the FAA isn't exactly speeding things up. Although there's no mishap investigation underway, the FAA recently announced that they're only now beginning to evaluate SpaceX's proposed license modifications. This leaves the launch schedule hanging in the balance. Interestingly enough, NASA officials provided an update on the Starship launch date during a meeting of the NASA Advisory Council. Kathy Kerner, a NASA official, shared that the Starship Test Flight 5 is expected later this fall. With fall starting around September 22nd, it looks like we won't see a launch until at least then, if not later. So we're in for at least another 3 weeks of waiting, possibly more. This new timeline, although disappointing, aligns with the current pace of both SpaceX and the FAA. Since the last tests, like the spin prime of S-30 on August 7th and the static fire of B-12 on July 15th, there hasn't been much movement. It's possible that SpaceX is focusing on upgrading systems at Chopstick for the Capture mission, but the real bottleneck seems to be the FAA. Their delay in evaluating SpaceX's proposal is puzzling, especially since no mishap investigation is required. This makes it difficult to predict when the FAA will complete their evaluation. Given the circumstances, an additional 3 weeks or even longer seems like a reasonable expectation for both SpaceX and the FAA to sort everything out. It's disheartening, especially since it's later than many of us had hoped. If NASA's estimate holds true, Flight 5 will happen at least 3.5 months after Flight 4, possibly more. This extended turnaround time contrasts with the progress SpaceX made earlier when they managed to reduce the time between Flights 3 and 4. So what are your thoughts? When do you think the new launch date will be? Let us know in the comments down below. And don't forget to like, share, and subscribe to keep up with SpaceX's ongoing journey. In related news, tensions between SpaceX and the FAA are escalating, particularly over environmental concerns in Texas and a recent dispute with CNBC. The FAA recently released a draft environmental assessment for SpaceX's Starship program, marking a key regulatory step. However, issues arose when the public comment period, which ended on August 29th, revealed allegations that SpaceX may have violated the Clean Water Act at its Boca Chica launch site. These claims cast doubt on aspects of SpaceX's license application and the draft tiered environmental assessment. As a result, the FAA postponed public meetings scheduled for mid-August and announced plans to issue a revised draft EA, further delaying SpaceX's plans for Starship launches. Environmental groups are becoming significant obstacles to SpaceX's ambitions, raising concerns about potential impacts on broader missions like NASA's Artemis program. The delays highlight the tension between environmental protection and space exploration, with speculation that the regulatory slowdowns might also be influenced by the strained relationship between Elon Musk and government officials. Musk's frustration with regulatory hurdles isn't limited to the US. His recent clash with the Brazilian government following the blocking of Starlink's financial accounts underscores his concerns about government actions stifling innovation. After Brazil blocked the financial accounts of Starlink, Musk was quick to clarify that SpaceX and X are two completely different companies with different shareholders. I own about 40% of SpaceX, so this absolutely illegal action by the dictator Alexandre improperly punishes other shareholders and the people of Brazil. In the US, SpaceX's challenges with the FAA, including delays in Starship and Falcon rocket launches, are particularly frustrating for a company known for its rapid development pace. Despite these challenges, SpaceX has significantly boosted the US's standing in the global space race, making it crucial for agencies like NASA, the FAA, and environmental groups to balance necessary protections with the need to advance technological progress. There's growing pressure on these agencies to reassess their procedures to support US space exploration goals without unnecessary delays. As SpaceX continues to push the boundaries, the outcomes of these regulatory challenges will play a critical role in shaping the future of space exploration and the US's position in the global arena. With that, the updates involving Starship have concluded. Let's now turn our attention to Polaris Dawn. SpaceX recently provided an update on the mission via X, noting, latest forecasts continue to show unfavorable weather conditions in the areas along Florida's coast where Dragon would splash down upon returning from space. Once teams identify the next best opportunities for launch and return of the Polaris Dawn mission, we'll provide an update. Falcon 9 and Dragon remain healthy and vertical on the pad at 39A. Musk echoed this cautious approach, tweeting, "Everything possible must be done to ensure astronaut safety. Safety remains the top priority," a sentiment also shared by Jared Isaacman, the mission's commander. Isaacman emphasized the importance of weather conditions and acknowledged the recent landing issue with the Falcon 9. He extended his apologies to those eagerly awaiting the launch, highlighting the team's commitment to patience, resilience, and teamwork. Isaacman's update reassured everyone that the crew remains ready, staying productive in quarantine, and can be prepared to launch within approximately 30 hours of receiving a favorable weather forecast. The weather has been a persistent challenge, thwarting a previous attempt at the Polaris Dawn mission. It's a reminder of the unpredictable elements that space missions must contend with. While weather is beyond anyone's control, the situation is further complicated by the FAA's potential investigation into the recent landing anomaly of Falcon 9. If the FAA proceeds with this investigation, it could introduce additional delays, much like the incident in July, which led to a pause in Falcon 9 flights. SpaceX has not mentioned this in their latest announcement, so the exact timeline for Polaris Dawn remains uncertain. Given these circumstances, it seems unlikely that the mission will proceed in August. Although August was expected to be an active month for SpaceX, these delays may push significant milestones into September. Hopefully, September will bring exciting developments, including Starship Flight 5, Polaris Dawn, and Crew 9 all lined up to launch. Moving on to another significant update, NASA has awarded a new contract for a lunar vehicle. Intuitive Machines, the company behind the lunar lander, launched on the IM-1 mission earlier this year. This year has been selected to deliver a payload to the moon's South Pole region in 2027. On August 29th, NASA announced a task order valued at $116.9 million through its Commercial Lunar Payload Services program, otherwise known as CLPS, awarding it to Intuitive Machines. The company also shared this news on X. Intuitive Machines will deliver 6 payloads with a combined mass of 79 kilograms to the moon's South Pole region. These payloads include contributions from NASA centers, the European Space Agency, or ESA, and the University of Colorado Boulder's Laboratory for Atmospheric and Space Physics. The payloads encompass a range of scientific experiments from biology and planetary science to space science, as well as a laser retroreflector array. Among the payloads, ESA's package for resource observation and in situ prospecting for exploration characterization and testing, or Prospect for short, stands out, as it will drill a meter below the moon's surface to search for volatiles like water ice. Chris Colbert, CLPS program manager at NASA's Johnson Space Center, emphasized the mission's importance, stating, "The instruments on this newly awarded flight will help us achieve multiple scientific objectives and strengthen our understanding of the moon's environment." This contract marks the 4th task order NASA has awarded to Intuitive Machines, underscoring the company's growing significance in lunar exploration. In fact, Intuitive Machines is the only company that has successfully landed a lunar lander on the moon in over 50 years. Despite some delays due to lessons learned from the first 2 missions, NASA is optimistic about the future. The agency promises to award more task orders next year, with intuitive machines poised to continue playing a vital role in these efforts. This year, the company has another lunar mission, IM-2, which is expected to launch on a Falcon 9. Alongside another lunar mission, Blue Ghost, these missions will once again showcase SpaceX's critical role in the ongoing lunar race. Stay tuned as we continue to follow these developments closely, from the challenges faced by Polaris Dawn to the advancements in lunar exploration. The coming months promise to be pivotal for SpaceX, NASA, and the broader space community. Unbelievable. The once mysterious operations inside Blue Origin's factory have recently been made public, accompanied by new revelations from Jeff Bezos. This disclosure has prompted a response from Elon Musk. How has Musk reacted? And what does this reveal about the advantages of SpaceX's vehicles over Blue Origin's New Glenn? The activities and systems within the Blue Origin factory have long been shrouded in mystery within the aerospace industry. What exactly goes on behind those doors? How is their vehicle development progressing? Until recently, these details were closely guarded secrets. However, a recent interview with Tim Dodd and his team on the Everyday Astronaut channel has provided valuable insights into Blue Origin's operations. We extend our gratitude to Tim Dodd and his team for this informative interview, and we encourage everyone to follow their X page and subscribe to their YouTube channel to support their continued efforts in bringing us more updates. The 1-hour interview offered a detailed tour of the Blue Origin factory, showcasing various components of the New Glenn rocket. Viewers saw the aft and forward sections of the booster, the liquid nitrogen and liquid oxygen tank sections, the second stage, and the fairing. Notably, the aft and forward sections of the booster have been recently tested and announced by Blue Origin on X. One particularly intriguing detail was Jeff Bezos' introduction of CNC milling machines and shaping machines. These machines are used to remove material from aluminum and lithium alloy plates, with Bezos noting that up to 90% of the material is removed using this method. An X account named Alex recently made an intriguing comparison. Blue Origin's New Glenn is a very expensive rocket to manufacture compared to SpaceX's Starship. For instance, the CNC milling used to remove 90% of the material from thick aluminum lithium alloy plates is extremely time-consuming, costly, and inefficient compared to using cold-rolled sheet metal in rolls. Musk responded to this tweet stating, "It is how most of the space industry makes rocket tanks. Works, but is expensive and production is slow." Musk's comments are supported by SpaceX's impressive production speed. Currently, SpaceX can produce 1 Raptor engine per day and completes rocket stacking in just a few weeks. In contrast, companies like Blue Origin, ULA, and NASA often face production timelines extending over several years. Interviews and previous tests reveal that the forward and aft sections of the New Glenn booster still appear quite rough, and the BE-4 engines have yet to make an appearance. When discussing what sets SpaceX apart from its competitors, 3D printing technology is a key factor. This technology creates objects based on a designed framework, ensuring uniformity and reducing errors. It also facilitates mass production. SpaceX utilizes this technology in its Star Factory system, which aims to produce up to 6 Starship version 2 rockets this year. Elon Musk has set an ambitious goal of producing 100 ships annually, potentially increasing to 300. In terms of production costs, companies like Blue Origin, ULA, and NASA face significantly higher expenses. Although Blue Origin does not disclose its costs, NASA has spent over $11 billion on SLS hardware. In contrast, SpaceX's Raptor engine only costs approximately $200,000. SpaceX also focuses on optimizing its vehicles, notably using stainless steel, which is both durable and cost-effective. This contrasts with Blue Origin's New Glenn, which Bezos revealed uses aluminum. In addition to these differences in speed and cost, Bezos made several other notable revelations in a recent interview, further highlighting SpaceX's competitive edge. Bezos recently discussed the performance of Blue Origin's New Glenn, specifically focusing on the speed of the booster landing leg deployment. According to Bezos, the landing leg opens in approximately 14 seconds. In comparison, SpaceX's Falcon booster is designed to deploy its landing legs in about 10 seconds. While theoretical comparisons suggest the Falcon is quicker, actual deployment times may vary. Faster and more flexible deployment is crucial for successful landings. Bezos also revealed details about New Glen's reusability, including its planned number of reuses and turnaround speed. Blue Origin aims for 100 reuses, but will initially target a vehicle capable of 25. This is significantly lower than SpaceX's goal for Starship, which is 1,000 reuses. The Falcon booster has already achieved 22 landings, approaching Blue Origin's reuse target, although it may take years for Blue Origin to reach this milestone. Regarding turnaround speed, Bezos stated that New Glen's turnaround time would be 16 days. In contrast, SpaceX aims to relaunch Starship within a day or even a few hours. Musk has set ambitious goals for SpaceX, including reflying the Falcon booster within an hour and launching Starship daily. Bezos has shared several new insights, shedding light on why Blue Origin's progress has lagged behind SpaceX. The upcoming debut mission of New Glenn will be a key test for the company's capabilities. Meanwhile, SpaceX is also gearing up for its next milestone with Starship. Share your predictions in the comments on which flight will launch first, Starship's Flight 5 or New Glen's first. Don't forget to like, share the video, and subscribe to the channel to stay updated on SpaceX's developments. Turning to New Glen's payload, the Escapade spacecraft, Rocket Lab is making significant strides. The company recently announced on X and their website that the twin spacecraft Blue and Gold have been shipped from their Long Beach, California facility to Cape Canaveral, Florida. Once at Cape Canaveral, the spacecraft will undergo 3 weeks of preparation, including performance testing, removal of protective covers, plug checks, and fueling. Regarding the mission process, the Escapade spacecraft will be launched aboard the New Glenn rocket and embark on an 11-month journey to Mars. Each spacecraft will be equipped with 3 advanced scientific instruments: the EMAG, or Escapade Magnetometer, the EESA, or ESA, which stands for Escapade Electrostatic Analyzers, and the ELP, which is short for Escapade Langmuir Probe. These instruments are designed to provide NASA with in-depth data on Mars, focusing particularly on its atmosphere and climate. With only a few months remaining until its scheduled launch, anticipation is building for the New Glenn mission and the valuable insights it promises to deliver. In contrast, while Blue Origin is still working toward its first orbital rocket mission, SpaceX continues to advance its capabilities with the Falcon 9. On August 16th at 2:56 p.m. EDT, SpaceX successfully launched a Falcon 9 rocket from SLC-4E in California, deploying the Transporter 11 mission. This mission included a payload of 116 small satellites in a sun-synchronous orbit. This mission is notable for its international scope, featuring spacecraft from countries such as Japan, Chile, the United Kingdom, and Australia. SpaceX highlighted the significance of rideshare missions, stating, "Rideshare significantly increases access to space for small satellite operators around the world." The spacecraft launched by Falcon 9 as part of this program include Earth observation satellites, in-space manufacturing technologies, robotics, student research projects, tech demonstrations for human spaceflight, and more. In addition to the remarkable feat of landing the booster, this launch marks the 340th landing of a Falcon rocket and the 20th successful landing of a Falcon booster at Landing Zone 4. This milestone underscores the growing impact of SpaceX's California launch infrastructure, with potential for further expansion if SpaceX secures SLC-6 on the West Coast. Furthermore, this mission represents the 80th Falcon 9 launch of the year, leaving just 11 more missions to match last year's record of 91 launches. Given SpaceX's current pace, it's anticipated that this milestone could be achieved as early as next month. Reaching 80 missions is a significant milestone for SpaceX as they set their sights on achieving 148 flights this year. With 3.5 months remaining, they need to complete 68 more missions. Along with this ambitious path, they will encounter several key milestones, including matching last year's record of 91 launches, surpassing the 100 flight mark for the first time in history, and ultimately reaching their target of 148 flights. SpaceX continues to assert its dominance in the aerospace industry, a position that will likely be challenging for competitors such as Blue Origin to match in the near future. We look forward to following SpaceX's journey as they aim to break records and set new benchmarks in the years to come. Ladies and gentlemen, introducing V2, the next generation of Starship. After a rigorous stacking process, this groundbreaking spacecraft is nearing completion and is ready to take the next steps that will undoubtedly shake up the aerospace industry. The world was abuzz in April when SpaceX founder Elon Musk set an ambitious goal to produce 6 V2 prototypes by the end of the year. At that time, many were skeptical, wondering how SpaceX could achieve such a feat. Now, as we approach the end of August, SpaceX has already taken significant strides toward fulfilling that promise, demonstrating their unmatched efficiency and innovation. Specifically, on August 23rd, at approximately 2046 CDT, the upper prototype section of S-33 was lifted out of Mega Bay 2's door area. This section, equipped with connecting tethers, was prepared for assembly. The aft section was already in position, waiting to be joined with the upper section. Within minutes, the two sections were connected by the tethers and lifted back into Mega Bay 2, where the upper section had originally been housed. This critical step suggests that the two parts will soon be welded together, marking the first time a Starship V2 prototype has reached this stage of production. It's a significant milestone in SpaceX's remarkable stacking process. To fully appreciate this achievement, let's review the process that led to the creation of this new giant. The journey began on July 13th when the S-33 payload section was moved from the Star Factory to High Bay. At that time, the section did not yet have its payload dispenser door. The following day, on July 14th, the nose cone, featuring several important design changes, was also transferred from the Star Factory to High Bay. Notably, this nose cone was equipped with new flaps, which were later confirmed to be part of the S-33 prototype. By July 22nd, the PEZ dispenser door section of the prototype had arrived at High Bay, ready to be combined with the payload section. Just 2 days later, on July 24th, the section that fully stacked the nose cone with the payload section was rolled out of High Bay and transported to Mega Bay 2, marking another significant step in the assembly process. On July 26th, the forward section of S-33 was moved from Star Factory to Mega Bay 2 and stacked with the upper section. Although images of this stacking process were not released, the progress was undeniable. Moving into August, the common dome section of S-33 was rolled into Mega Bay 2 on August 4th. And immediately the upper section, now stacked with the forward section, was connected to the common dome via hooks. By the 8th of August, the liquid oxygen section of S-33 was also delivered to Mega Bay 2, where it was attached to the upper section, continuing the rapid assembly process. On August 15th, the first aft section, which did not yet have the aft flap, was transported to Mega Bay 2. Although the specific movements inside Mega Bay during this time were not clearly documented, it was evident that significant stacking was taking place. Around this time, the methane header tank featuring new designs appeared in the front yard of the bays, signaling further progress. On August 19th, the transfer jig, also known as the fuel downcomer, was brought to Mega Bay 2. This component is critical as it connects the liquid methane tank to the engines on the ship. The jig features one large pipe that connects to the 3 sea-level engines and 3 smaller pipes that link to the vacuum engines. The liquid oxygen downcomer, which connects to the liquid oxygen header tank at the nose cone to the center engines, was moved to Mega Bay 2 the following day on August 20th. Finally, on August 23rd, the aft section, the last piece of S-33, arrived at Mega Bay 2. It was then connected to the rest of the prototype, completing the stacking process as I mentioned at the beginning. With this, the S-33 stacking process is officially complete. In the coming days, SpaceX will likely focus on installing the aft flap, which will signify the end of the production phase for this prototype. This entire process from start to finish took just 41 days, an extraordinary feat in the aerospace industry. Typically, companies take months or even years to achieve what SpaceX has accomplished in just over a month. This rapid pace of assembly highlights how SpaceX continues to set itself apart from other aerospace companies, driving driving innovation and pushing the boundaries of what's possible. Once the assembly of S-33 is complete, this prototype will be ready for the next critical phase of its development. The first of these steps is cryogenic testing, which will take place at the Massey test site. Notably, S-33 will be the first V2 prototype to undergo testing at this facility. If the cryogenic tests are successful, S-33 will return to the production site for engine installation, likely featuring the newly released Raptor 3. Following this, S-33 will head back to the Massey test site for a static fire test. If all goes according to plan, S-33 will then await its companion, likely the B-15 booster, to move forward with additional steps such as the wet dress rehearsal and ultimately the launch. Speaking of the launch, if SpaceX proceeds with its current plan to launch all V1 prototypes, S-33 and B-15 are slated for Flight 8, potentially scheduled for early or mid next year. While specific details are still uncertain, the progress of S-33 marks a significant milestone for the Starship program. As SpaceX aims to complete at least 6 V2 prototypes this year, we can expect to witness similar processes with the remaining 5 prototypes. Beyond this, SpaceX has even more ambitious goals on the horizon, particularly Elon Musk's vision of producing up to 100 ships per year, with an ideal target of 300 ships annually in the future. To achieve this, SpaceX will need to ramp up production to a speed of 1 to 3 days per ship. There are undoubtedly many challenges ahead, but with the Star Factory and the base systems in place, SpaceX is well equipped to meet these demands. The successful progress of S-33 serves as a strong foundation for the challenges and achievements that lie ahead. The goal is clear, and now it's time for SpaceX to accelerate toward it. Are you ready to follow this thrilling journey? If so, respond with V2 in the comments section down below. Then be sure to like, share the video, and subscribe to our channel to stay updated on SpaceX's development journey, including the exciting progress of Starship V2. In contrast to the significant progress of Starship, NASA's Space Launch System, or the SLS, may be facing yet another delay. Specifically, NASA is seeking to extend the contract for a key component of the SLS known as the Launch Vehicle Stage Adapter, or LVSA for short. This cone-shaped structure, which stands 8.4 meters tall and tapers from 8.4 meters across at its base to 5 meters at the top, is used to connect the Interim Cryogenic Propulsion Stage, or ICPS, to the core stage on the Block 1 version of the SLS. However, the LVSA will not be utilized in future versions of the SLS, as the ICPS will be replaced with the larger Exploration Upper Stage. Originally awarded the Teledyne Brown Engineering in 2014 under a $200 million contract, the production of the LVSA was scheduled to be completed by September. However, in an August 14th procurement filing, NASA announced its intention to extend this contract until at least September of 2026 to produce the third and final LVSA for the SLS-1. This version of the SLS will be used for the last time before the program switches to SLS-1B for Artemis 4. Moreover, the proposed extension includes several options for additional extensions, potentially extending the contract by another 9 months until June of 2027, and possibly even further to December of 2029 if additional revisions are implemented. Such delays could have a direct impact on the Artemis 3 schedule, which is currently set for September of 2026. However, NASA has yet to provide an updated timeline for this mission. These delays highlight ongoing issues with the NASA SLS program, which has been plagued by significant delays, technical problems, and escalating costs. Recently, NASA also identified quality concerns with SLS components that are under Boeing's responsibility. Given the persistent challenges and setbacks associated with the SLS, it may be time for NASA to reconsider its approach. Shifting focus to SpaceX's Starship could potentially enable a faster, cheaper, and more efficient return to the moon. We've wrapped up the Starship section here, and now it's time to shift our focus to Japan, where a significant mission related to space debris is taking shape. Japanese space sustainability company Astroscale has recently secured a $90 million contract to remove a bus-sized rocket stage from orbit by the end of the decade. This project, funded by the Japanese Aerospace Exploration Agency, or JAXA, is an extension of Astroscale's ADRAS-J mission, which recently conducted a close-up orbital inspection of a 12-year-old upper stage of a Japanese H-2A rocket. The new mission, called ADRAS-J2, is slated to launch as early as 2027. It will involve using a robotic arm to capture the 3-ton, 36-foot-long, or 11-meter rocket stage and guide it into Earth's atmosphere to burn up, demonstrating a critical space cleanup technology. The H-2A upper stage, which has been tumbling in a 370-mile-high or 600-kilometer orbit since it deployed the Greenhouse Gas Observing Satellite (GOSAT) in 2009, is just one of hundreds of spent rocket bodies in near-Earth space. The uncontrolled nature and age of this rocket body present significant challenges for its removal, but the ADRASJ inspection confirmed that the rocket's payload adapter, which will be used for the capture, remains intact. Unprepared objects in orbit pose an additional challenge as they have not been prepared with any technologies that enable docking or potential servicing or removal, Astroscale stated. Japan's commitment to addressing space debris is commendable, even if it currently focuses on vehicles of their own making. Space junk poses a significant challenge for the aerospace industry, and addressing it is no easy task. A potential partnership between Japan and SpaceX, which has its own plans to tackle space debris with its Starship, could represent a major leap forward in addressing this critical issue. This collaboration could prove to be a powerful combination in solving one of space exploration's most pressing problems. The Two Towers has come true, and now we eagerly await the return of the king. Yes, the second launch tower at Starbase has completed its stacking process in record time, once again capturing the world's attention. This milestone provides a crucial foundation for SpaceX, boosting confidence as they prepare for the next flight, where the Starship booster will be caught by the Mechazilla arm for the first time. While many challenges lie ahead, SpaceX has meticulously prepared for every possibility. The second launch tower has been the most eagerly anticipated structure at Starbase this year. On August 21st at around 7 a.m. EDT, the T-Rex crane's lifting jig connected to Module 9, the final piece of the tower. Just over an hour later, the module was lifted and welded into place, officially completing the basic structure of the tower. Now it stands tall, offering a striking view alongside the first tower nearby. To commemorate this milestone, SpaceX shared a tweet proclaiming second launch tower stacked as the newest addition to Starbase, with Elon Musk adding his own reaction, the two towers. This tweet nods to Musk's previous comment late last year, where he suggested the next stage of the Starship program should be called the Two Towers. While the FAA's schedule had set a target completion date of August 15th, meaning the project was about a week behind, it's worth noting that SpaceX managed to stack all the sections in just a month, a significant improvement over the 9 months it took to stack the first tower. And it likely won't impact the overall schedule. Phase 3 of the plan will commence from this milestone and continue until January 28th next year, focusing on building additional systems like the Mechazilla arm, the OLM, with a water-cooled steel system or flame trench system below, the tank farm system, the fuel rail, and more. With this foundation, SpaceX will push the launch cadence to new heights, initially targeting the 25 flights per year that they are aiming for. Currently, SpaceX is advancing the Star Factory, the Massey test system, and the Starship V2 launch preparations to meet that goal. More importantly, with the addition of the new launch tower, SpaceX plans to eventually catch the Starship stages in the future. This will mark the moment when SpaceX achieves full reusability of their giant rocket, a feat no other organization has accomplished. This could begin as early as Flight 6 or Flight 7. Although many steps remain, the completion of the second tower stack has laid a crucial foundation for SpaceX's future endeavors. Are you ready to enter this new phase? If so, respond with the number 1 in the comment section down below. Then be sure to like, share the video, and subscribe to our channel to continue following SpaceX's development journey. And soon enough, a significant milestone in the new era of space exploration will be set with Flight 5, where SpaceX plans to catch the Super Heavy booster using the Mechazilla arm for the first time. Currently, SpaceX is finalizing preparations for this flight, with a wet dress rehearsal test still ahead. Additionally, SpaceX is waiting for the necessary approvals from the FAA. Given the current pace of progress, I anticipate the launch could take place around mid-September. Feel free to share your own predictions about the launch date in the comment section down below. So, What can we expect from this flight? Most of the procedures will remain consistent with previous missions. SpaceX will launch Starship from Starbase, and around T plus 2 minutes 45 seconds, the separation process will occur, with the Super Heavy booster beginning its descent. Meanwhile, Starship will continue its journey into orbit to complete its tasks. At approximately T plus 45 minutes, Starship will begin its re-entry, eventually landing in the ocean, likely in the Indian Ocean, more than an hour after liftoff. While these are the basic steps, this upcoming flight will introduce two critical new elements. First, the task of igniting the engine in space may be performed with the ship. This test was skipped in the previous two flights, so it's about time. Testing the engine in space is crucial for SpaceX as they refine their vehicles and prepare them for longer missions in the future. However, the most significant change will be the attempt to catch the Super Heavy booster with the Mechazilla arm. Musk recently shared a video highlighting the process, underscoring SpaceX's commitment to this groundbreaking effort. Unlike previous flights where the Super Heavy was soft-landed in the Gulf of Mexico, this time it will return to the launch site. This maneuver will require far more complex procedures. The grid fins will need to be much more active in guiding the booster's descent. While the system has performed well in the past, this attempt will be considerably more challenging. In addition to the grid fins, the engines, particularly the gimbal engines, will play a crucial role in steering the Super Heavy and managing its deceleration. The entire descent is expected to take around 10 minutes from an altitude of more than 60 kilometers. This estimate is based on the Falcon 9's descent with some adjustments for the more complex nature of the Starship booster's landing. As the booster approaches the launch tower, the process will become increasingly intricate. The grid fins and engines will need to work in perfect harmony to guide the Super Heavy into position. The speed must be precisely controlled, neither too fast nor too slow. Most importantly, the booster needs to align perfectly with the chopstick arms. Once aligned, the chopstick arms will open, and the Super Heavy will need to move exactly into position. The arms will then slowly close around the booster, securely holding it in place. After catching the booster, the chopstick arms will adjust its position and rotate to place it back on the orbital launch mount next to the launch tower. Of course, we're talking about a process that ideally goes smoothly, but no one can guarantee that everything will unfold exactly as planned. This attempt carries significant potential risks. Firstly, the navigation process itself can be problematic since this will be the first time both the engine and grid fins will undertake such a complex task. We've seen instances in previous flights where the Super Heavy's engines experienced failures at critical moments. Such issues could cause the booster to deviate from its intended flight path. Once the flight phase is over, the approach and landing become even more challenging. If the engine or grid fins encounter problems earlier in the process, SpaceX could opt to land the booster in the ocean. However, as it nears Starbase, alternative options become scarce. The booster might not slow down in time or may fail to align perfectly with the chopstick arms. In the event of a failure, the Super Heavy could collide with the tower, the chopstick arms, or other infrastructure, potentially causing a catastrophic explosion. To make matters worse, there are numerous fuel tanks nearby which could exacerbate the situation. The flight hardware isn't the only concern. Chopstick itself could malfunction. The most critical issue would be timing. If the chopstick arms open or close too early or too late, the subsequent catching or holding step could fail, causing the booster to hit or fall off the chopstick despite operating correctly. This would lead to the same disastrous consequences mentioned earlier. Beyond the technical challenges, external factors like wind and fog could also disrupt various stages of the process. Despite these challenges, SpaceX has several reasons to be confident in this endeavor. SpaceX has prior experience landing the Super Heavy booster during the previous two flights, even though issues arose. Notably, in Flight 4, SpaceX successfully landed the booster for the first time. During that flight, SpaceX demonstrated strong navigation and deceleration capabilities which will be invaluable in this next attempt. As for the chopstick system, SpaceX has recently made numerous upgrades and conducted tests with B14.1, ensuring the ground systems are well prepared to catch the returning booster. All of these factors are built upon SpaceX's advanced technological foundation. A decade ago, the idea of a rocket landing vertically or on a drone ship in the middle of the ocean seemed impossible. Yet SpaceX achieved it and has since made it routine. While it's natural to feel concerned or skeptical about this unprecedented challenge, I hope you will support SpaceX as they continue to push the boundaries of space exploration. And once successful, we'll move on to the next ambitious target: landing both the booster and the ship. That's when the second tower will come into play. This new system, combined with the first tower, will work together to catch the entire Starship, marking the first time a rocket has been fully landed and recovered. Honestly, I've never felt more excited than I do now. The two towers and the upcoming flight will serve as the first notes in a new era for the Starship project. As time goes on, more towers and flights will join them. That's when we'll witness the return of the king, as in the king of the future aerospace industry, Starship. This October, Blue Origin, a company that's been operating for nearly 25 years and known for its suborbital dominance, will make its first orbital attempt, with the new launch date officially confirmed. Their determination seems higher than ever, but are they really ready? This mission could be a significant step forward for Jeff Bezos and his team, or it could end in disappointment. The stakes are high as Blue Origin ventures into the challenging realm of orbital spaceflight. Will this mission mark a new era of success, or will it highlight the challenges that still lie ahead? Blue Origin, often regarded as a space industry giant with immense potential, has long faced criticism for its inability to reach orbit. This year, however, the company has demonstrated a renewed sense of purpose, highlighted by significant changes such as a new CEO, the return of Jeff Bezos, and tangible progress with their New Glenn rocket. Their primary objective is clear: to achieve their first successful orbital flight. On August 23rd, Blue Origin made a pivotal announcement revealing a new launch date for New Glenn's inaugural mission. Now scheduled for no earlier than October 13th, this mission will see the rocket carrying NASA's Escapade spacecraft to Mars, lifting off from Launch Complex 36, otherwise known as LC-36. The revised date represents a slight delay from the previous target of September 29th, giving Blue Origin just a month and a half to finalize preparations. While this announcement underscores the company's strong commitment to its goals, there's a healthy dose of skepticism about whether Blue Origin can meet this ambitious timeline. While this announcement underscores the company's strong commitment to its goals, there's a healthy dose of skepticism about whether Blue Origin can meet this ambitious timeline. The mission is not just another test flight, it involves launching NAR's Mars-bound Escapade, a significant payload that underscores the company's boldness and confidence. For NASA to entrust Blue Origin with such a mission on their very first orbital attempt speaks volumes about the potential they see in New Glenn. In the lead up to this critical launch, Blue Origin has been meticulously preparing, conducting hardware tests, moving and stacking components at the launch site, and ensuring that all systems are ready for the big day. The mission's payload has already been transported to Florida by Rocket Lab, further emphasizing the seriousness with which Blue Origin is approaching this mission. Successfully reaching orbit would mark a watershed moment for Blue Origin, elevating their status from a promising contender to a significant player in the space industry. Achieving this milestone would not only silence long-standing critics, but also cement New Glenn's position among the leading rockets in the field. This success would validate Blue Origin's technological advancements and strategic investments, showcasing their capability to compete at the highest level. New Glenn's successful debut would also set the stage for it to directly compete with other prominent rockets, including SpaceX's Starship. Although New Glenn may not be designed for Mars missions in the way that Starship is, its involvement in supporting missions related to Mars and other deep space endeavors would send a powerful signal to SpaceX and its founder Elon Musk. By demonstrating that New Glenn can handle high-profile payloads and missions, Blue Origin would establish itself as a credible alternative in the evolving landscape of space exploration. This mission could indeed be a pivotal turning point for Blue Origin, marking their transition from a company with significant potential to a formidable competitor in the race to explore and utilize space. Successfully reaching orbit would not only enhance their reputation but also solidify their role in future space missions, setting the stage for further innovations and achievements. But Blue Origin faces significant challenges as it prepares for this pivotal mission. Although Blue Origin has made substantial progress, key components of the New Glenn rocket have yet to be fully assembled. The absence of BE-4 engines, a crucial part of the rocket, is particularly concerning. Despite being featured in promotional videos, these engines have only seen limited use, such as in ULA's Vulcan debut flight. This delay has already pushed back several of Blue Origin's plans, and the lack of engine installation adds to the uncertainty. The rocket still needs to undergo essential tests, including cryogenic, static fire, and wet dress rehearsals. Each of these steps is crucial for ensuring the rocket's readiness, but can be time-consuming and prone to issues. Blue Origin has recently faced setbacks setbacks, including the explosion of a New Glenn upper stage during movement to a storage hangar and another failure during a stress test. These incidents highlight potential issues in the manufacturing process. Although these hardware failures are not directly related to the upcoming mission, they raise concerns about the overall quality and reliability of Blue Origin's components. The company will need to thoroughly investigate these failures and ensure that the new hardware meets safety standards before proceeding. As New Glenn's inaugural mission approaches, questions about its success are inevitable. Unlike ULA, which has extensive experience with Atlas and Delta rockets, Blue Origin is new to orbital launches. This lack of experience poses a risk. Even if New Glenn launches successfully, there's no guarantee that it will avoid issues experienced by other new rockets. For instance, ULA's Vulcan, despite a successful launch, had complications that impacted its payload, the astrobotic Peregrine Lunar Lander. The payload for New Glenn's first mission is NASA's Escapade spacecraft, which will explore Mars' atmosphere and weather. Although not as costly as some other missions, Escapade is vital for NASA's Mars exploration plans. A failure in this mission could jeopardize NASA's objectives and affect future missions. A failed mission could also be a setback for Blue Origin in its ongoing rivalry with SpaceX. SpaceX's achievements, particularly in its ambitions to colonize Mars, set a high bar. Another failure would not only damage Blue Origin's reputation, but also impact its future prospects in the competitive space industry. All in all, while Blue Origin is pushing forward with ambitious goals, the road to their first orbital flight is fraught with challenges. The company must address these issues effectively to avoid further delays and setbacks, ensuring a successful launch and solidifying its place in the space industry. With the debut of New Glenn fast approaching, Blue Origin stands on the brink of a major milestone that could shape its future trajectory. This inaugural flight is not just a test of engineering prowess, but a decisive moment that will influence the company's place in the space industry for years to come. The pressure on Blue Origin is palpable, as they have secured a prestigious contract to launch up to 12 Kuiper satellites for Amazon, a venture that represents a significant leap forward. The success of this mission is critical not only for validating New Glenn's capabilities, but also for supporting Amazon's ambitious plans to enhance global internet coverage. Any issues with the inaugural flight could lead to considerable delays, potentially derailing Blue Origin's schedule and impacting Amazon's strategic objectives. Adding to the challenge, the company has encountered problems with the hardware for subsequent New Glenn flights, which underscores the need for a flawless performance on this first mission. The stakes are particularly high given Blue Origin's decision to prioritize New Glenn over competitors like SpaceX for the Kuiper missions. A failure at this stage would be a significant setback, potentially tarnishing Blue Origin's reputation and complicating future negotiations. This choice reflects both a bold strategic move and a high-risk gamble. Jeff Bezos and his team have staked a great deal on the success of New Glenn, making this debut mission crucial for their future prospects. Beyond the immediate mission, New Glenn is set to play a pivotal role in NASA's Artemis program, with a planned contribution to Artemis 5 in 2029. This long-term commitment adds another layer of pressure, as Blue Origin must ensure that New Glenn is not only successful now, but remains reliable and ready for future crewed missions. The company must avoid the pitfalls experienced by Boeing's Starliner, which faced numerous delays and technical challenges that ultimately hampered its progress. Ensuring that New Glenn meets these demands is essential for Blue Origin's credibility and future involvement in such high-profile missions. Additionally, New Glenn is poised to handle sensitive payloads for the National Security Space Launch Program, shortened to NSSL, which involves critical military and government missions. Blue Origin must navigate these responsibilities with precision, avoiding the backlog issues that have plagued ULA's Vulcan. Maintaining trust and reliability in these operations is crucial for securing future contracts and establishing a strong foothold in the competitive space industry. The competitive landscape presents another significant challenge. SpaceX's extensive and evolving fleet, including Falcon 9, Falcon Heavy, and Starship, sets a high bar for Blue Origin. Emerging players like Rocket Lab and Sierra Space also pose formidable competition, with Rocket Lab's impressive record of over 50 orbital flights and Sierra Space's innovative projects making waves in the industry. Blue Origin must not only match but exceed these competitors' achievements to carve out its niche. As New Glenn's debut flight draws near, the road ahead is fraught with both opportunity and uncertainty. The outcome of this mission will be a crucial indicator of Blue Origin's readiness and capability. How the company addresses these challenges, navigates the competitive pressures, and delivers on its promises will shape its future in the space industry. With global attention focused on their progress, Blue Origin has a significant opportunity to demonstrate its potential, overcome hurdles, and set the stage for for future achievements in space exploration. In the early 2010s, following the retirement of the space shuttle, NASA embarked on the development of a new rocket called the Space Launch System, or SLS for short. For this ambitious project, NASA selected Boeing, a long-standing partner and a well-known company from the earlier era of space exploration, to support the construction of the core booster and exploration upper stage. At the time, NASA's choice of Boeing was driven by the need for reliability and experience. However, it seems they may have overlooked the potential drawbacks of relying on a company with older tech to build a next-gen rocket. An approach, in hindsight, appears contradictory. After more than a decade, the consequences of this decision are becoming increasingly apparent. As we know, the first SLS rocket launched during the Artemis 1 mission in 2022 came at a staggering cost of over $23 billion for the entire system, with more than $11 billion attributed to the SLS itself. Despite these costs, NASA plans to continue using the system in future Artemis missions. Notably, Artemis 4, which is slated for September of 2028, will feature a new version of the rocket, the SLS-1B, still being constructed by Boeing. However, recent developments have cast a shadow over this decision. On August 8th, NASA's Office of Inspector General, or OIG, released a report following an assessment of the current project. The report delivered a harsh critique of Boeing's work on the SLS-1B at the Michoud Assembly Facility in New Orleans, focusing on two all-too-familiar issues: quality and cost. Let's start with the concerns regarding quality. The OIG report noted that Boeing's work has not met international standards or NASA's stringent requirements. One particularly alarming example highlighted in the report involved a liquid oxygen fuel tank dome, a critical component of the SLS core stage 3. During an April of 2023 visit to Michoud, inspectors found the dome segregated and awaiting a decision on whether it could be safely used due to welds that failed to meet NASA specifications. According to the report, these quality control lapses are largely due to a shortage of trained and experienced aerospace workers at Boeing. The OIG criticized Boeing for inadequate training and oversight, leading to safety and reliability concerns. Additionally, many experienced workers have left Boeing for newer aerospace companies offering better pay. These issues have resulted in numerous corrective action requests, or CARs, issued by the Defense Contract Management Agency, or the DCMA, which oversees Boeing's work on the SLS. Between September of 2021 and of 2023, DCMA issued 71 CARs, 24 of which were rated level 2, indicating serious issues that involve critical safety hardware and cannot be corrected immediately. The DCMA even considered drafting a new level 3 for severe nonconformities. Despite these warnings, Boeing has shown little progress in addressing these issues. The report stated, according to DCMA officials, Boeing's process for addressing contractual noncompliance has been ineffective, and the company has generally been non-responsive in taking corrective actions when the same quality control issues reoccur. Moreover, Boeing has been using the Earned Value Management System, or EVMS software, to measure progress. However, the Department of Defense disapproved of this system back in 2020, citing Boeing's inability to produce a realistic baseline delivery date for the exploration upper stage due to ongoing deficiencies in its EVMS. Not only are there quality concerns, but Boeing's work is also driving up the cost of the new SLS version. The report estimates the cost at $5.7 billion, which is $700 million higher than NASA's 2023 agency baseline commitment. The EUS alone is expected to cost $2.8 billion, over 3 times the initial estimate of $962 million in 2017. These are staggering numbers. To put it into perspective, the cost of the EUS alone is nearly half of the $11 billion spent on the entire first SLS prototype used in Artemis 1. So why does a rocket with such questionable quality come with such a high price tag? It seems the answer lies in outdated and inefficient technology. Because the technology is not up to modern standards, numerous fixes are required, leading to delays and soaring costs. The report indicates that the delivery of the EUS from Boeing has been delayed from the original estimate of February of 2021, set back in October of 2016, to April of 2027 as of October of last year. And given the current issues, it's uncertain whether Boeing can meet this deadline with the required quality. The final cost remains unknown, and it's unclear whether it will surpass the cost of the Artemis 1 prototype. The OIG report made 4 recommendations to NASA, including developing a quality management system for Boeing, applying penalties for quality standard violations, analyzing cost overruns, and coordinating with DCMA to bring EVMS into compliance. NASA has accepted 3 of these recommendations but has rejected the one related to penalties. In conclusion, the report states, given Boeing's quality management and its related workforce challenges, we are concerned these factors could potentially impact the safety of the SLS and Orion spacecraft, including its crew and cargo. More than ever, it seems that Boeing should be removed from this program immediately. The SLS itself may need to be reconsidered. It is too expensive, carries potential risks, and lacks the longevity needed beyond lunar missions. If you agree, respond with "kick it" in the comments section. Don't forget to like, share the video, and subscribe to our channel to stay updated on SpaceX's development journey. NASA's challenges with Boeing extend beyond the SLS. They are also grappling with significant issues related to Boeing's Starliner spacecraft on the International Space Station. When NASA launched the Commercial Crew program back in 2014, they selected both SpaceX and Boeing to build crew spacecraft. Notably, Boeing was awarded $4.5 billion, significantly more than the $2.6 billion given to SpaceX, reflecting NASA's confidence in Boeing's capabilities. However, the Starliner spacecraft has encountered numerous issues during testing, leading to repeated delays in the crewed test flight. Even before its scheduled launch, Starliner faced persistent problems, including fuel leaks. Despite these setbacks, the spacecraft was sent to the ISS, and now Boeing is struggling with its return. Currently, Starliner is plagued by issues with helium leaks, reaction control system thrusters, and undocking software. These problems have forced NASA to consider sending SpaceX's Dragon to rescue the Starliner astronauts, with a final decision expected soon. It's clear that Boeing's performance with Starliner does not justify the substantial funding they received. It's important to remember that Starliner has yet to complete any missions under its Commercial Crew program contract. Meanwhile, the clock is ticking, with only 6 years remaining until the planned retirement of the ISS in 2030. Can Starliner meet NASA's requirements within this time frame? Much like the SLS, Starliner reflects Boeing's slow and outdated technology. If NASA were to conduct an assessment of Starliner similar to the OIG's review of the SLS, it's likely that many more issues would come to light. Given these ongoing problems, it may be time to reconsider Starliner's role and explore more efficient alternatives. If you agree, please reply with "drop it" in the comment section down below. NASA has been fortunate to have the support of SpaceX during some of its most challenging times, and if they decide to part ways with Boeing, SpaceX is poised to continue as NASA's most reliable partner. Or perhaps its only partner. When it comes to the ISS, it's clear that SpaceX's Dragon is more than capable of taking over the tasks initially assigned to Boeing's Starliner. The superior performance of Dragon underscores the stark differences between Boeing and SpaceX. As for NASA's lunar ambitions, I believe that even if NASA were to cancel the SLS program, SpaceX's Starship would be more than capable of completing the remaining objectives. In fact, eliminating the SLS could simplify NASA's plans considerably, allowing them to cut other costly and high-risk projects such as the Mobile Launcher, Orion spacecraft, and Lunar Gateway. Some might argue that SpaceX's Starship hasn't yet proven its ability to replace SLS in the Artemis program, but let's take a closer look. In just over a year, Starship has completed 4 integrated test flights, something that the SLS has yet to achieve. Moreover, these flights have demonstrated milestones no other program has reached, including the landing of both rocket stages, which is the first step towards a fully reusable rocket. Reusability is a key advantage that makes Starship superior to the SLS. Building on this foundation, SpaceX is pushing forward in all aspects to meet the Artemis schedule. Looking at the broader roadmap, SpaceX has ambitious plans for thousands of Starship launches per year. In contrast, we've never seen similar projects for the SLS, which is primarily limited to moon missions. This limitation further reinforces the argument for canceling the SLS program. Now is the time for NASA to enact a comprehensive change. Slow and inefficient, Boeing's approach no longer aligns with the current direction of space exploration. To maintain its leadership in the space race, the US should focus on removing barriers and investing in modern, fast, and efficient companies like SpaceX. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.